Forget everything you thought you knew about data centers. What if I told you the future of computing is happening right now? In ways you can barely imagine? Prepare to be amazed as we unveil the revolutionary technologies and architectural shifts that are redefining performance, power, and environmental impact in data centers across the globe. Welcome to the Data Center Innovation Map. Let's go! Imagine a world where data centers are no longer massive, energy sinks, but power-efficient, highly automated marvels. What kind of innovations are making this a reality? And how will they transform everything from cloud computing to AI? Join us as we explore the groundbreaking advancements set to revolutionize how we store, process, and access information in the very near future. The relentless demand for cloud services and AI processing is pushing hyperscale data centers to new limits. The core driving force behind much of this innovation is artificial intelligence, specifically machine learning and generative AI applications, which demand ever-increasing processing power, often reliant on GPU-based servers and specialized AI-optimized hardware. This surge in demand necessitates a complete rethinking of traditional data center designs. We are moving away from older models towards larger buildings and entire campuses, specifically engineered for immense power capacities. AI-optimized builds are becoming the norm, characterized by compact, high-density designs capable of housing the most powerful computing equipment. Innovative cooling solutions are becoming standard to manage the extreme heat generated by these high-density environments. Liquid cooling, once a niche technology, is rapidly transitioning to an essential component of modern data centers. Direct-to-chip liquid cooling, for instance, is no longer an exotic concept but a critical standard for supporting modern workloads. This allows data centers to efficiently operate incredibly dense racks and AI hardware, which are predicted to reach power densities exceeding 300 kilowatts per rack by 2026, and potentially over 600 kilowatts by 2027. We're seeing a massive adoption of disaggregated infrastructure, which strategically separates compute, storage, and networking components for unprecedented flexibility and efficiency, allowing resources to be allocated dynamically as needed. Sustainability is no longer an option, but a critical imperative for data center operations, especially given the growing power consumption challenges posed by AI. Data centers are under immense pressure to adopt greener solutions, not only to address regulatory requirements but also to meet ambitious climate commitments. Renewable energy integration is crucial, with massive solar farms and even localized wind turbines playing a significant role in reducing the carbon footprint of these facilities. This includes a projected significant increase in power derived from solar energy. Advanced power management systems are continuously optimizing energy consumption, utilizing AI-driven load balancing to reduce wasted electricity and ensure power is used as efficiently as possible. Furthermore, the exploration of alternative power solutions is gaining traction. Natural gas generation is being considered as a readily available and scalable option, while small modular nuclear reactors, or SMRs, are being explored as a potential long-term power solution, with announcements regarding their adoption expected to accelerate. Water conservation is another key focus, with innovations in closed-loop cooling systems and even advancements in air cooling technologies, suitable for colder climates, minimizing water usage. The proliferation of IoT devices, the rollout of 5G networks, and the increasing demand for real-time applications are necessitating processing data closer to its source, leading to the explosion of edge computing. This means data is processed at the network's edge, reducing latency and bandwidth consumption for applications that require immediate responses. Miniaturized and ruggedized data centers are being deployed in unconventional locations, from cell towers to smart factories and even remote industrial sites. The number of edge sites is expected to grow significantly, fundamentally changing the distributed nature of computing. Edge-to-cloud orchestration is becoming critical. seamlessly integrating local processing capabilities with central cloud resources for hybrid workloads, ensuring a cohesive and efficient data flow across the entire infrastructure. This also contributes to geographic diversification, as data centers expand into new regions and secondary or tertiary markets to optimize power procurement and mitigate regulatory risks. AI and machine learning are revolutionizing data center operations, moving beyond just handling data to actively managing the infrastructure itself. We are seeing the rise of the self-managing data center, where AI predicts potential failures and autonomously optimizes resource allocation. Robotic Process Automation, or RPA, is automating routine yet critical tasks like server provisioning, patching, and configuration management, freeing up human engineers to focus on higher-level strategic initiatives. Predictive maintenance, which leverages a vast array of sensor data, combined with sophisticated AI algorithms, is dramatically reducing unplanned downtime and extending the lifespan of expensive equipment. By identifying potential issues before they escalate, the integration of AI is also optimizing data center operations and management, making them more resilient with redundant power pathways, advanced cooling systems, and multi-path network connectivity. Beyond the rack, future frontiers are already being explored. While still in its embryonic stages, the integration of quantum computing is already shaping architectural considerations for future data centers, preparing for a paradigm shift in processing power. Advanced security protocols are continuously evolving to protect these increasingly complex and interconnected systems from ever-sophisticated cyber threats. The landscape of data center ownership and investment is also changing, with new operator and financing models emerging, as energy providers and various investors become more deeply involved in the data center sector. However, challenges persist, particularly with supply chain issues, leading to longer delivery times for critical components, which can delay data center construction. Retrofitting existing data centers to improve power utilization, efficiency, and embrace newer technologies is also a crucial and ongoing effort. Interconnection remains a key factor for all data centers, ensuring seamless data flow and communication across different infrastructures. The convergence of rising power requirements and explosive data center growth presents a generational investment opportunity, making expert advice and guidance fundamentally important in this rapidly evolving sector. Strategic factors like energy efficiency, location selection, advanced cooling concepts, and scalability are paramount for companies reliant on data centers. Proactive planning and alignment with the right digital infrastructure partner are crucial for hyperscalers navigating this dynamic and demanding environment. The future of data centers isn't just about bigger buildings or more powerful servers, it's about intelligent, sustainable, and adaptive infrastructure that can meet the boundless demands of a data-driven world. The innovation map is constantly being redrawn, and we're just getting started.